Hello, everyone, and welcome to this webinar on system engineering and model-based engineering. We are, myself, Mark Young, with our co-presenters, SMS Think Tank, are happy to invite you to this webinar. Before we start, we will just do a quick overview of our companies. First, for those of you who do not know us at XLM Solutions, we consider ourselves a complete PLM service provider. We've been around since 2005, so we bring many years of experience and best practices within the PLM industry. And we pride ourselves with being highly respected for both providing excellent business and technical expertise around PLM. We are both a Dassault business partner, a SolidWorks certified professional service company, and an ARIS partner. And we really, dedicate ourselves to always being on the forefront of continuous initiatives within the PLM realm, new best practices, new technologies, etc. And just to give the scope of work we do, regarding various PLM systems, we do everything from general implementations to customizations, integrations, for example, integrations to ERP systems, data migrations from legacy systems, and training and support. And we're happy to work together with SMS Think Tank to also work and provide model-based system engineering solutions as well. I'm going to hand it over to my colleague Frank at SMS Think Tank.
Yeah, thank you, Mark. You see this on the screen. We are a leader in the systems modeling and simulation, where we bring the various worlds from the system engineering perspective with computer-aided engineering together. And as you will see, our focus is to help enabling sustainable innovation, improving engineering maturity. And by the way, throughout the presentation, when we were talking about MBSE, you see quite a few aspects of this. What does it mean, maturity, and also from a sustainable perspective. Could you go to the next slide, please, Mark? And we work really across the various industries. We are doing consulting, we are doing coaching, we are doing education, and we are developing also process and system models in order really to help the digital transformation of the various businesses. And you see this is custom and tailor-made. And you see also one of the charts here where we are talking about the innovation maturity. You will hear a little bit more during the presentation how in aspects of model-based system engineering. Next. On the agenda and the content side, first on the next slide I will give you very briefly what is it what we want to get to you with this webinar. Then we will talk about the model-based system engineering aspect, the landscape, complexity, how it is part of the digital transformation before diving into more, even though still from a high level, from a fundamental perspective, the role of requirements before we are wrapping it up and turn that portion and turning it over to XLM presentation where we show a Dassault vision for our FLP with even a video demo and a brief CATIA Magic overview. Next one, please. And from an objective perspective, really the idea, and this is the title is saying, is an introduction to introduce you to the model-based system engineering. That is a subset, and because we call ourselves system modeling and simulation think tank. So, but MBSE is a key element of the whole thing, and you will see this how this all fits together from a maturity perspective. What needs to be enabled to go from the document-based to the model-based portion, etc. And this is where we are talking about the various building blocks, and that's why one of the key elements is when we are talking about requirements. Very brief introduction here. So with that, because we want to put our emphasis on the presentation, the material, the content, with this, Mark, if you could switch to the presentation now, that would be great.
Will do.
And if there are questions, please put them into the chat box. And afterwards, we have a Q&A, we will answer those. With that being said, let's talk about current and emerging landscapes, engineering complexity, and MBSE as part of digital transformation initiatives. First of all, business challenges. We are a global economy. Like it or not, despite all the geopolitical challenges, we are interconnected and depend on each other. We are facing faster than ever changing and evolving technologies. And we live in an age of data information, and we have to make sure that the data and information is available to us fast, and we can make use of that. Practitioners are finding it increasingly difficult to communicate their needs to management. They have to learn. And of course, we are facing the digitalization, visualization, and collaboration issue. And this is where we are also, from a culture, from a system, organization, and from a product perspective, talk about complexity in general. What are associate engineering trends? We are talking about the product and ecosystem increased complexity from the various details. You see this here, environmental, electronic assembly. There is much more demand for flexibility and choice. It might be from an individual perspective, from a regional, from a cultural perspective. We look into improved product quality and robustness guarantee upfront. This is where we talk about new manufacturing, increased regulatory requirements that need to be met upfront as examples. And we talk about, at that point, about digital transformation. Real-time and virtual access to information has to be guaranteed, and we need to do this upfront. And that gets us from a business perspective, not just from a research perspective, into sustainable innovation. So what does it mean, for example? Yes, we are continue to operate in an ever leaner environment, and the demand for accountability is continuing to grow. But some examples, mega trends for transportation industry. We know them: electrification, autonomous driving, mobility as a service. For healthcare industry, or for medical industry, is personalized healthcare. And so have other industries their own mega drivers, but they all have one thing in common: complexity, system, embedded system. And for the medical device industry, for personalized health, a visual example here. We deal with them on a daily life, and we have to make sure they work and they are properly designed upfront. And in order to achieve this from a sustainable innovation perspective, we are talking about systems modeling and simulation, where model-based system engineering is a subset. We are talking IoT, big data, Industry 4.0. And of course, from a culture and process perspective, we are talking about iterative and collaborative approaches. And from a maturity perspective, we have to get to the point where we are talking about cognitive engineering, where we are definitely talking about an implemented digital twin. At that point, we can talk about innovating at a speed. The business pressure is driving the move to simulation-driven design, as I mentioned before. And we have highlighted here a few keywords. And from a complex product challenge perspective, we are talking about a systems design. They are more complex. We need to be able to identify them much earlier in our development process. Cross-functional, and we need to overcome the silos. But most of all, we need to make sure we have a proper requirements management and authoring process in place, and Ed will talk about this more. That gets us into the complexity issue. Various industries had various success over the years how to deal with complexity. But in our day and time, the system complexity is increasing even further. The required time to market is decreasing further. And the main culprit is embedded software complexity. And that gets us to the point: are we integrating various systems properly in our day and age, the way the market is demanding? Aren't we just releasing products too fast? Do we have proper development processes in place in order to support those new requirements, those new demands? And thus, are we talking about having a proper system engineering process in place, even going further down there, model-based systems engineering. And here to visualize this here a little bit more for the medical device industry and transportation industry, a futuristic surgery lab, or on the road, how the cars communicate with each other, enable autonomous driving capabilities. Huge complexity, and we have to be able to deal with this upfront. In order to get to that point, we have to transform our businesses. So what is model-based systems engineering? Is a formalized application of modeling to support system requirements, design, analysis, verification and validation activities, beginning in the conceptual design phase and continuing through our development and later life cycle phases. And I have highlighted here underneath with an emphasis on leveraging virtual representation, various domain models, and digital models. One thing what I would like to highlight here, just understanding the basics is one thing. We have to understand each implementation is like an individual fingerprint. For each organization, for each industry, applying MBSE is different. It has its own challenges. But some of the drivers are very similar, and I have them highlighted here again. We are looking into more innovation, embedded system, interactive, reduce the total product costs upfront. Cost-effective and reliable product is introduced into the market. And there's a demand for flexibility of choices as a driver. And as I mentioned before, one size doesn't fit all. A few words about the engineering V. Each company needs to develop their own. And what you see here, we have the V overlaid with the life cycle. And that is what I mentioned before, very much so. But in order to do this successfully, that's why I have it highlighted here in the last bullet, a successful implementation of MBSE will include changes in organization, process, and technology that must be carefully understood, and the correct plans be developed and carried out to ensure all entities agree to embrace this cultural transformation. Coming from the silos and live with those is not acceptable anymore. We have to overcome those. We have to get to a point where we have integrated system models, authoritative sources of data information, closed-looped and collaborative approaches where all members have access to this and interact with each other at every stage of the life cycle. I mentioned before, we need to be able to shift virtually the system thinking to the early stages of the engineering development process. Only that will help us to meet all those requirements the market is throwing at us. Some of the benefits of system engineering and MBSE are listed here and what the results are. We are not going to dive into this in all the details. There's much, much more that needs to be discussed, but they are common sense benefits and results. From a digital transformation perspective, I would like to highlight here a few critical success factors. And this is where we have to make sure that there's proper investment is being done. And I'm going back to organization, process, and technologies and highlight here for the organization side. Keep it simple. Innovation culture, education, increased communication, collaboration, some elements on the process side, and of course some on the technology side. And what are the resulting? Reduced time to market, reduced typical physical prototypes, reduced reworks, increased reliability, lower warranty costs. And when we are looking into this, in order to achieve this, we have to talk about engineering maturity. We have to get to the point where leaders on the innovation side, we innovate at the speed of thought. We need to understand the data as a foundation. And the platform approach needs to leverage a common system engineering and product data model, well-written requirements, platform program project, system definition, product structure, lifecycle configuration management capabilities. And companies need to understand at what level of innovation maturity they operate in order to be and stay competitive. And from a system innovation perspective, we have to understand it is needed to support a unified data model. That gets us also overall when we are looking into where are we from a mature perspective and business perspective. And here you see this for the medical device industry as an example. We need to be able to get to systems modeling and simulation to the cognitive level. From a traditional, where we shift from a physical to virtual perspective. And what are some of the essential factors to increase maturity? You see this here on that screen here. You see model-based system engineering is here on the right, actually still before cognitive principles. One thing what I would like to highlight here is requirements already show up at document-based development approach. Further improvements are being done in the model-based development approach. And you better have a proper and comprehensive requirements approach introduced when you want to have successful model-based system engineering implemented in your company. And that is my transition to add to discuss further the role of requirements.
Thank you, Frank. Now let's talk about the role of requirement. The role of requirements is absolutely foundational in any successful model-based systems engineering strategy and implementation. In this section, we're going to cover at a very high level some of the fundamentals of requirements. Specifically, system requirements, the types of requirements, what concept of operations means, some clarifications regarding their use, structure, some of the traps that people often fall into, and how to properly break down requirements. Now, this is one of my favorite cartoons. And that is, in this particular cartoon, it addresses how well someone addresses requirements as part of their MBSE journey. And in most cases, this is the norm, unfortunately. So we see the manager asking Wally if he has time to gather the product requirements ahead of time. And the manager says, hey, I want you to start designing this right away. Otherwise, it looks like we aren't accomplishing anything. And of course, Wally puts his feet up and says, of all the products, I like the Doom ones the best. And we'll talk about why that is pretty much something that's realized in many companies across many different industries. Well, let's begin with system requirements. System requirements play a major role in systems engineering. They form the basis, the foundation of integration, of systems integration and verification activities across all those different engineering disciplines. They act as a reference for validation and stakeholder acceptance, meaning that when you have completed your design and you've completed all the verification of the particular requirements, do they in fact satisfy the original stakeholder needs and wants? Do they validate what the stakeholder originally asked for? And they provide a means of communication between the various centers of technical brilliance across many different engineering disciplines that must work together. They might have expertise in particular areas of whether it be controls or hydraulics or thermal, or it goes on and on and on. And these areas of brilliance typically are isolated, and communication in and out of them is challenged in many cases. So good system requirements do bridge that. Of course, you need other means to help with that collaboration. We'll get to that. They also provide a roadmap for field uses, and they determine the impact of change if they're properly linked, if you have them traced and also linked together properly, you can determine the impact of a particular change. Before we get deeper, we just want to briefly outline, why are you doing this? What are you gaining? What are the benefits out of this? And it's essential that good requirements are authored and properly managed throughout the product lifecycle. And what you want to do is you want to ensure by defining good requirements and properly authoring them, writing good requirements, and ensuring that you have a test case associated with them to prove the viability of the requirement. It will not be compromised by doing this properly. And what you'll have is you'll properly define the requirements, and you ensure you have traceability and impact. You can identify the thread, the change history. You have optimized designs. And what you do is you really have a good plan for your test cases. Of course, management loves the cost controls, as do we all. You have the ability to reuse particular, let's say, modules that have been proven before. You have a stakeholder agreement in the end that says, okay, this is what I asked for. This is what you're giving me. There's collaboration and communication between those disparate engineering groups that we just talked about. And what we're doing is we're enabling sustainable innovation. Many people do not realize how many different types of requirements there are. So in some areas of management, they think requirements as being a single scalar entity, which it is not. There are many different types of requirements, and I've listed just some. This is not exhaustive. But let's say, for example, you say, what are our initial requirements? What are we looking to do? And that is based upon our stakeholder, our customer requirements. They're very high level. A lot of people refer to this as the concept of operations. They are specific and precise, and they're measurable. In this case, I'm using an automobile of what a customer would expect to be fulfilled. Then we have functional requirements. That's a detailed breakdown of the actions that need to be accomplished. They need to satisfy particular inputs and the behavior and outputs of the system, and they need to drive the application architecture. And of course, that leads into performance requirements. And these are the targets for how our system is going to operate, how it's going to be measured, and quantity, quality, and coverage, timeliness, readiness, and it goes on. But let's go beyond this. Let's take the next step. And that is, with the types of requirements that exist, we have to ensure that we are adhering to the best engineering practices while ensuring simplicity. Because there are, as part of what we discussed, functional requirements, performance, usability, interface, operational, modes and states, adaptability, physical constraints, and you can see this, they're just mounting. And we're looking at, as we go through this, so many different, and it goes well beyond this. There must be an appreciation, not only for these type of requirements, but things that are not even addressed here, like risk. How do you deal with risk? And so what we need to do, and these two slides are only meant to introduce you to the fact that requirements are not just a simple scalar entity. They are complex. They interact with one another. They have to be carefully architected. They have to ensure their thread or their traceability. And there are many other things to do to ensure that our requirements are properly written, properly maintained, and that we have them for all of the characteristics that we're designing. I'm going to say that one again. And we have all of our requirements. They're complete. There's no requirements missing. That is one of the biggest gaps that we see in industry, working with many different customers. There are, at times, requirements that are not even defined. Hey, we've done that for 70 years. We're going to keep on doing it because it worked then. It should work now. Little do they know that technology has changed. Now in their processes, they're doing things that they don't need to do. They have redundancies built in. It's chaotic. It's a situation where, without having a handle on these requirements, they've lost control of their engineering processes. And now, when you're trying to adapt, or if you're trying to embrace model-based systems engineering best practices, you'll find out very quickly how much of a problem it's going to be. This requirements is the #1 contributor to false starts for people embracing model-based engineering. If they don't have it right, garbage in, garbage out. So let's start at the beginning. And that is, what do we get? How do we start with the requirement? Now, this presentation is not going to cover every aspect of requirements. This is introduction, a very high level. And we can go very much in depth in the future, but this right here, we're just going to start with the concept of operations. And what is that? The concept of operations, it's a foundational document, and it frames the overall system on what the stakeholder wants. Here is that infamous V model. You've probably seen it more times than you really want to, but just for the sake of simplicity, it's being brought up here just to talk about that first step in that V model. The objective is to describe the system's environment and how it will be used. The input is going to be that application knowledge. In this case, once again, vehicle requirements. It'll be for an automobile. I'm just going to use one industry. This goes across all industries. What the value prop is and the functional concept. The output is going to be a validation plan. And that validation plan is going to go over to that, ensure that this system validation is being performed properly. And in the end, we are providing the customer what they asked for. So what we'll do is we'll dive down a little bit deeper. It's to clearly convey a high-level view of the system that's being worked on, that's being developed, that each stakeholder can understand as well. And a good ConOps, it answers, this is very important, and we're going to dive a little bit deeper on this too. Who, what, when, where, why, and how questions about the project from the viewpoint of each stakeholder. The customer, who is asking for this? Who are the stakeholders involved in the system? What are the elements and the high-level capabilities of the system? Where is the geographic and physical extent of the system? When is the sequence of activities that will be performed? And why is the problem or opportunity being addressed by the system? How will the system be developed, operated, and maintained? We'll give you an example. This is just a generic who, what, when, where, why, and how. And now what we'll do is we'll go into an example. For concept of operations, we have who, and we're going to deal with an automobile that will have to satisfy certain characteristics. This is what the stakeholder wants. If you don't give the stakeholder what he wants, he's not going to buy that automobile from that OEM. He'll go somewhere else. So who do they want to address? Who is the stakeholder? The stakeholder are families of 2 or more children. And what do they want? They want a touring vehicle that adheres to all U.S. regulatory rules regarding safety and fuel economy. They want it safe, and they want to have it very fuel efficient. Where? Well, we're going to look at the North American market first. When? Oh, an 18-month development and production cycle, or to production. Why? Well, the research trends that we have made, we've discovered, all the research that we've done, there are families that are driving to more vacation destinations rather than any other mode of transportation. How? Well, they have to involve smart technology to ensure the performance standards. They want to exceed the current year touring model with the same maintenance procedures. And what they want to do is they want to ensure that all their objectives are met. So I've provided a sample of the concept of operations from which we drive down and we derive all of our other requirements from them. Now let's not go any deeper than that, because this is supposed to be a higher level. We can in the future address this at a much more detailed level, but this is to give you a flavor. So now let's look at some clarifications, things that confuse many engineering groups that are going down that MBSE journey. So let's make some of these clarifications. We have requirements analysis. So what we're trying to do is we're trying to convert customer desires and preferences into specific measurable features that can be used for design and test. Now, keep in mind, we're going to be going over some terminologies, and this is what confuses a lot of people. What is the difference between a requirements document versus a requirement specification and a design document versus a design specification? Because even in some cases, vendor use these interchangeably. But let's look at, by pure definition, a document is a specification. Either a document or specification, it's a collection about it or of information about a product at various times during its product cycle. Now, let's take a look at what's the difference between a requirement and a rec spec or a requirement specification. A requirement is a statement of one thing a product must do or a quality it must have. One thing. A requirement specification is a collection of a set of requirements that are being imposed on a design. So what we have is we can have other information into that requirement specification, and it can, regarding its design verification and maintenance, and much more accountability, much more could be added to that. But when we start writing documents, we want to make sure that we have an objective for each requirement. Typically, you really want to avoid having 10 different objectives into one requirement, because if you pass 9 of those objectives and one of them fails, well, that one requirement has failed because of 1/10 of the way it was written. So we want to make sure that we know that a requirement usually contains one thing a product must do, and a requirement specification is a combination of a series or a big set of requirements. Now, just a final note on some clarifications, something that's often confused, and that is requirement specifications versus design specifications. Sometimes these are used interchangeably, and unfortunately, that is not correct. And this will lead a group down a path which will cause a lot of confusion. And in the end, it really produces very poor results. A requirement specification states what the stakeholders need. Remember, need. It is underlined and bold. A requirement specification states what the stakeholders need in terms of features, performance, and so on. A design specification states how that design will meet the requirements. What will be the trade-offs between the different approaches? How will we meet those needs? How is underlined. That is key to understanding the difference. Remembering that this is a very high level when we talk about requirements and their participation within MBSE. So now we have to look at the structure. And this is by no means all-inclusive, but to give you a flavor, when we write a requirement, it has to adhere to a certain structure. And what we want to do is we want to make sure that we provide assumptions, positive statements, and we also want to make sure that the statement states what is needed, not how. We just got done talking about that. And you want to ask yourself why you need that requirement. And requirements are complete sentences with one subject, one positive predicate, and a criteria. And here's an example. We'll use this as the car. The subject is the car. The positive predicate is shall accelerate. Notice the word shall. You'll be seeing that a lot. If you are writing requirements, you probably know it very much already. Now, what is the criteria? The criteria is that car is going to shall accelerate. The criteria is 0 to 60 in less than 4.5 seconds. That's measurable. So it has a subject, a positive predicate, and a criteria. And that is a typical structure for a well-written requirement. Of course, this is a very high level. When we get deeper, you'll see that there's much more that goes into writing requirements. But for those of you that are not, let's say, deeply involved in your MBSE journey, if you're not very far along the way, or if you're just starting and you really don't have a good appreciation for the role that requirements play, then this is very appropriate. Now, in writing good requirements, one must avoid traps. Now, I don't know if you've come across these traps before, but these are things that people will encounter when they are trying to produce a component or a subsystem or a system or whatever it may be. They're reading a requirement and they say that there are, let's say, ambiguity and things that are unverifiable. For example, in the automotive industry, the info system, the info entertainment, or whatever it may be, must be user-friendly. Okay. How do you test for user-friendly or easy or rapid? How do you test for a minimize or maximize? Or, as you can see, there are many different risks. You want to avoid large lists of bullets because then, like I said, you only have a partially completed requirement, and now there will be complications when you try and determine how far along you are in a particular project. And you want to make sure that you don't have multiple requirements embedded into a requirement. It's almost like a list. And you really want to avoid negativity. For example, shall not provide. You want to stick to positive statements. And you can read through this. You want to make sure that you really are distinguishing those wants versus needs. Okay, let's wrap this up. In parting, there are some key messages. One, MBSE combines those traditional systems engineering methods and best practices with digital tools and modeling languages that support the integration of various systems engineering disciplines, structural, electrical, mechanical, thermal, it goes on, and their associated stakeholders. And it's through the availability of a formal modeling language which can describe the systems and engineering standards and tools which enable integration of a systems model with existing discipline models. Next, get education. And when we say get education, we say not just one time and now you're educated, right? No. As systems engineering progresses, as the adoption progresses, as your maturity progresses in adopting MBSE best practices, your education must mature along with that proportionally. So a group that's educated, as their maturity increases, should continue their education. And management should be educated. And as the maturity increases, their education increases. Because as many have tried, adopting MBSE by fire hosing education into various groups is a great recipe for a false start. Each industry and company would be better served by making the journey by what MBSE means to them rather than what vendors are telling them what to adopt. And how do you do that? Well, we're going to get to that, but just remember that key bullet. It's critical that as you progress in your journey, you embrace it by what it means to you, how you would best benefit. Because each MBSE implementation is like a fingerprint. They're all different. One size does not fit all. So, next, identify management sponsors, executive sponsors that are willing to support you because there will be times when you need that collaboration across various teams and you need an executive sponsor to ensure that effective communication and collaboration, as well as much more. Now, if you think that textual requirements are going to be riding into the sunset anytime soon, they will not be, because they're critical. There's critical data in there, regulatory. The government, there's many different agencies, both government and non-government, that are not MBSE based. They're based on textual documents. So you have to make sure, unless you are totally divorced from those groups, that it's the chain with the weakest link. You have to make sure that you account for all those requirements that will be handed to you from all those other agencies, and regulatory is a big one. Now, when we get to that sponsor, this is very important, because a central governance organization within an enterprise, you have to, and it's pretty clearly written here, to maintain their sanity when embracing this. It's complex, and there are cultural transformations, not changes, transformations, which you might constitute as a change, but it's much more. So to do that, an executive sponsor is critical to ensuring that a government organization is developed, it's structured properly, and executed. And that organization has, let's say, the power to affect change. Now, MBSE is a complex initiative. Don't expect overnight adoption. It's going to take small steps. It's going to be crawl, walk, run, and there'll be a lot of crawling. And seriously consider, now when we talk about what does it mean to you? When I said that earlier, what does MBSE mean to you rather than what somebody's telling you to adopt? We recommend that you consider assessing your current as-is state, your systems engineering readiness. Where are you right now? Where do you want to be within a certain period of time? And then look at those gaps, and look at how you're going to address those gaps, and develop a roadmap and a schedule for that. So do that assessment of yourself, the as-is and the to-be, for your readiness. By the way, technology is not going to be your driver here with tools. Focus on standards. The tools will follow. You don't know what you don't know. But standards, you do know that you need to develop a digital thread. And be prepared to lead your solution providers based upon where you want to be.
All right, thank you, Ed, and thank you, Frank. As mentioned, Frank and Ed are here to work with you and show you how to best implement a model-based system engineering strategy. We here at XLM are here best to take that data, how you define your requirements, and best manage that data, those requirements data or other MBSE data within a PLM system. One of the PLM systems that we obviously work closely with is Dassault's 3D Experience. And what you see here is not that it's a V diagram, but sort of the Dassault's vision of the V diagram, starting with requirements, going down the V to functions, logical design, and then starting up the V with engineering items, the CAD, the physical structure, the manufacturing MBOM, and then this is really extending it out, manufacturing and building that product through, through processes and simulation of the manufacturing platform. But the key thing is requirements are key throughout the structure, along with individual simulations that can be done, whether it's electronical, physical, or plant simulations to make sure everything is done properly. Dassault really has two flavors of helping you manage requirements. It has what we consider the enterprise flavor, which is web-based, It's based on a trigram called TRE, and it allows you, through the web to manage requirements, and then anyone who has access to Innovia can see, access, link data to those requirements. It also has a solution, that went by Cameo, No Magic, now it's called CATIA Magic, which is more of a thick client that is used to create and view requirements. As this is a thick client, this is more of a work group solution, but it has a lot of functionality to model and design requirements in a very graphical manner using various system languages and plugins. The TRE requirement management is very tree structured based, where you can decompose requirements into sub requirements, different testing criteria, etc., and actually build a master requirement document out of it. And we'll show you a video here. So in this case, you're seeing a requirement structure that is being built. You can have different pictures, models. Basically, you can have a rich text editor to help build and structure that requirements document or requirement structure. I would say it can look like a document, but it's definitely not a document per se. And then you can build different subsections, and these are the sentences of what those requirements are. And like Ed said, they can work on to help best properly structure those requirement statements, but we are here to help manage those and set up the system to best manage them in the system. In this case, you're building a requirement, you're linking pictures to it, and decomposing those requirements into a structure that can be used to help build the structure. Also, there's life cycle on requirements. So you can control the states, whether they're in work, being reviewed, or released, now to be used in a downward process. The other solution is, as I mentioned, CATIA No Magic, and that's more of a thick client based. CATIA No Magic is been a solution has been out there for 19 years. So acquired it from Cameo a few years ago, and CATIA No Magic, has different roles within it. It has a architect role, which provides a high level way of building structures at an architect point of view. A cyber systems engineering role, which is really the key, I'd say, requirements engineer, MBSE, engineer would be using that type of role to, again, build requirements, do data modeling, review and merge data together, etc. A software architecture review, which is a little bit lighter than the engineer, again, for mainly modeling software processes and requirements, and then a collaboration studio simulation toolkit role, more geared for viewing or simulating requirements. And then one thing that was mentioned briefly, I don't know if it was picked up upon, originally for software designers, they were using a lot of what's called UML modeling, or Unified Model Language, which was a language to help model what the software is going to do. Within CATIA Magic and really the whole model-based system engineering world, they've extended that to what they call SysML, or system modeling language, which really extends UML, overcomes certain limitations, and makes it much more useful for the true system modeling-based engineering system. And obviously, CATIA Magic is making use of SysML. This is a quick screenshot of CATIA Magic, where various systems, functions, and requirements are being modeled within the system. And then maybe the big question out there is what are the differences between the TRE or the Innovia-based requirements management, and CATIA Magic. So there is no right or wrong answer what solution to use. It really depends on your own use case and the user profiles that are going to be using the system. A lot of times if you're deploying a full PLM system across the enterprise, across locations, then maybe CATIA Magic is not necessarily needed because it is that thick client that needs to be installed. And therefore, mainly the 3D experience TRM is the preferred solution because everything's based on the web. So, one differentiator is this going to be an enterprise system or more of a work group solution? But it really depends on the, again, the exact use case and how in-depth the modeling needs to be. Also, it should be noted that both the TRE and CATIA Magic today have different data models within 3D Experience. So CATIA Magic, there's a solution called CATIA Magic Power By, which allows you to take all that CATIA Magic and put it in the system, but it is a different data model than the TRE. And then there are a solution or a data hub type of product that comes with it that can allow you to synchronize the CATIA Magic requirements to the TRE requirements, though my colleagues at Dassault said it's not the preferred solution and better solutions are coming. But hopefully that gives you an overview of the differences between the two and why you would go with one over the other, with the key differentiator being that web-based enterprise or more of a work group solution. With that though, and we want to definitely save time for questions, but we want to say thank you, and if you have any questions, please type them in to the question section or the chat, and we'll get to them. The first question that came up was, and bear with me, but how does sustainability, is used within the context of model-based system engineering? So I don't know if Frank, if that's something you can take as a question, and if I have to unmute you, Frank, let me know.
Yeah, I'm unmuted here already. Yeah, sustainability, and you see quite often when we talk sustainability is from an environmental perspective way too often associated. What we need to focus on is from a business perspective, the way how we do things. That means why are we saying MBSE is helping to enable sustainable approaches is because you heard Ed mention this several times also from a reuse perspective. Digital thread, that means you can find easily information. It is a single source of truth available, and models that have been generated before can be made available over and over again. Collaboration. So your whole business process is not an ad hoc anymore. It is well defined. It can be shared. People can make use of it in an easy way, and this way you don't waste time and invent something what you have done before. So very brief, but that's a sustainable thing as from a business perspective. And MBSE, because you transfer this into a digital space, into a model space, is a key enabler for that.
Thank you. The next question, does 3DX have the same functionality as CATIA Magic for system modeling simulation? So I'll take that question. When talk about 3DX, I assume you mean the TRE or the requirements management module within 3D Experience. I would say it does not have the same functionality today. It's a little bit lighter, but still does a very good job at modeling and decomposing requirements at a web-based level and an enterprise level. But for the in-depth, hardcore simulation and SysML modeling, probably CATIA Magic would be the right solution there. So hopefully that addresses the question. There was a question, what is the best way to record business case? And what is the right stage to move from a business case to requirement gathering phase? Frank, do you want to take that one? Or Ed?
Yeah, I'm just thinking maybe Ed, maybe you can do that portion and I can add to this if needed. Because
Sure.
this is touching upon the requirements section quite a bit.
Right. Actually, this ties into, I think, one of the biggest questions that we've encountered when we work with each client, and that is, how quickly can I fail? Or how quickly can I have a false start? Because it starts with requirements. If you take a look from the very inception, the start of your job doing any type of MBSE applications, it's garbage in, garbage out. If you don't have a good feel on how your requirements have been authored, how they've been managed, you're going to fail. The education is tied in with it. So to answer your question more directly, I just wanted to lay that down foundationally. To answer it more directly, someone, before they even embark upon this, they need to do self-assessment, whether that's with the assistance of some other individuals or whatever. But where are you right now? What is your readiness to adopt any MBSE best practices? How ready are you? You might think you're ready, but you really should take a close look. And then what you do is do that an assessment. From that assessment, determine where you want to be in 5 years, 3 years, whatever the criteria is. Then what you do is you measure the gaps that you've seen between where you are and where you want to be. A lot of times you don't know what you don't know. And this is why it's pretty handy to enlist some people that are experienced in this. Remember these keywords. Every journey toward MBSE, every implementation, every adoption of best practices is like a fingerprint. There's no two alike. It's like a snowflake. There's no two alike. They're all different because they all have to meet the needs of each group, each individual group. So the assessments, of where you are, where you're going to be, the gap analysis, put together the recommendations on how you're going to get there with a roadmap. I know that's a very high level, but I'm reading into this question, and I'm reading into probably a few more questions. If you don't do it, you're going to have a false start. And we typically get called in after there's been at least 1 to 2 false starts. So that's where you really want to be. If you want to get really detailed, I can give you a detailed response, but I think I wanted to address it that way.
All right, thanks, Ed. Another question just simply asked if the slide deck will be available. So yes, the recording of this will be available. And if you want the actual slide deck, please, contact us individually and we can provide it. I know it's getting close to the hour. We have a couple more questions, and we will stay on to answer all of them. But for those of you who need to leave, once again, thank you. And please reach out to us if you have any offline questions or any input on this webinar or future webinars you may be interested in. But we will continue with questions. Another question is, and again, maybe Ed or Frank, you can answer this, but what is the top reason why MBSE fails in companies? And maybe that's something, Ed, you already just alluded to in your response, but if you want to
I will
address that too.
Because I knew that was coming. That had to be coming. Because this is the #1 question that everybody always asks us. Okay, I can give you a rundown, more detail. Why do we encounter these false starts? And the reason being, people believe that you just put in a turnkey piece of software and then you turn the dial and guess what? You're doing MBSE. When actually what you need to do is you need to determine, once again, your readiness. A lot of people are not ready. Why are they not ready? Because MBSE involves a cultural, let's say, growth. I used to say cultural transformation, but that was kind of like maybe a little bit too harsh in some executives' minds. But it involves, let's say, an embrace of determining how we're going to do this, we have to budget money. We know that we are going to go in and have some education. We know that what we need to do is we need to ensure, and this is where the biggest failure is, besides education, is our existing state-of-the-art system isn't ready. I don't. There's many times when we'll go in with a client and we say, well, do you have? Oh, first question we ask. So you have all your requirements. They're all fine. Everything's great. You know where to go for them. You've captured all your tribal knowledge throughout the years. It's easily accessible. It's manageable. And oops, I'm sorry, one just dropped. It's accessible and everything works great. And they laugh. They laugh and they said, we're nowhere near that. Ah, well, guess what? You better fix that before you try to, start embracing, uh, characterizing models with requirements when you don't have them to begin with, or they're poorly written, or they're in 11 different formats. And I know I'm hitting nerves with people out there because this is where people go, whoa, we didn't know this. Remember that executive management, they have embraced their position to be, to manage budgets, but it's the people that are in the trenches that say, logically, this is how this has to work. A lot of times that's not communicated to upper management, so they know what they're in for. It might be culture shock because so many people have told them, oh, this is so easy to do. Yeah, you just do this and you're done. Well, guess what? You do it, you're not done. And then why do we spend this money? We're not prepared. False start. The other thing is, like I said, education. And I'll say this quickly. A lot of people say, okay, we're going to do a 1-hour class in education and then we're all educated. That's not the case. MBSE is complex. So what you need to do is establish a baseline of education for the practitioner, for the manager, and for the executive. So they all understand where they are and what they're up against. And then as you mature in your systems engineering progress in your journey, that education must be maintained. So you say, okay, we're here now. Now we have to take the next step in education and go deeper. People that try and fire hose education and try and get all education into 1 hour for an executive and it's done, it doesn't work. So education is ongoing. It matches with maturity. So that's another key point. And you have to have a sponsor. There has to be an executive that sponsors this and a good, strong governance team. So I'm going to end really by saying the governance team, people representing the different disciplines, have to have representation in the journey. And there has to be an executive sponsor there that says, okay, I understand and you're updating me. I see what needs to be done. I understand. I can communicate that with my peers so there's no shock. And we're new way of thinking, new way of adapting. By the way, there's we even wrote a white paper on these landmines. So feel free, we can provide that white paper to you. But yeah, there are many pitfalls, and I'll end there because I don't want to scare anybody away.
And then unless anyone has anything else, actually, there's one more question maybe for you, Ed. And it says, can you compare the main differences between the current approach to system engineering, document-based, and MBSE in layman's terms?
Oh, sure. Well, this is one of those, another myth. And that is, let me start by saying that people think that, okay, if I'm going to adapt or I'm going to adopt MBSE, requirements-based is going to go away, and that's one of my stepping stones, and that's a myth. And it's a myth because think of the automotive industry, think of the aerospace industry, think of just about any industry where you have regulatory requirements. When the government's involved, you have regulatory requirements. And there are other ones like that as well. They're paper-based, they're not model-based. So if you think you're going to be jumping away from from paper-based anytime soon, no, it's going to be a hybrid type of operation. So let me, in layman's terms, talk about it. What people have is they will have a system or a process. It could be a very, let's say, dynamic, very, let's say, powerful requirements-based system. And that works great for them. Some people, very small companies, or whoever, they might be using, let's say, Windows-based tools to capture their requirements. Whatever it may be, what you're doing is you're documenting a requirement in a format that is not connected with a particular model. The model could be a piece of software. It could be a 3D model. It could be a 2D model. It could be a 1D or 0D. It could be a dynamic simulation. But basically, you have a group of requirements that are really outside of the control of a model. And once again, don't be confused about what model could be anything. But the model based is where you're actually absorbing those requirements into it. So as you pass a model from group to group, whether it be going from a pneumatic, dynamic, or I'm sorry, a thermal, or a controls, or a structural, there's requirements that are accompanying that model that are critical, and people will generate their own models from it. So don't think there's only one model. You have a system model, but maybe the hydraulics people will say, oh, we're going to take that. We're going to do this hydraulics based upon this system and see how it fits in there. The controls people will say, oh, there's a system model we're using as a basis. It has requirements embedded in it. And now we're going to put our control code on that. We're going to have our own submodel, our own discrete model, but we're going to be using that as our reference. So you're passing this information back and forth rather than passing a group of documents. And the documents, and this is where it gets kind of nasty, is unless you have a system like what Mark was talking about, it's going to be hard to control it. You're going to be looking for data, and you'll find out in many times, and here we go, this is probably going to hit another nerve, I don't know where to find it. Half the problem is trying to find the person that has that information. And if that person has been retired, well, why are we doing it this way? Well, we've done it this way for 70 years. We'll keep on doing it. That's not a good answer, because you won't be in business very long.
If just to circle back, to what Ed said and what I showed, how PLM systems, or specifically 3D Experience, can manage requirements. Think about what he said. You might get a Word or a document listing requirements, whether they're federal requirements or supplier requirements, but you need to ingest them into a system that can manage them, and then link those requirements to different models or data within that system. And hence, that's a lot, what we're showing, where we can take a document and then digest the data in that document to actual objects or links within a system to be linked and associated to for that full model-based engineering, along with managing the data.
Well, Mark, thank you. I think you described it in fewer words than me. I like your response.
If I could add here two very brief comments, and because we mentioned this in my portion of the presentation very briefly when we are talking about increasing maturity. You saw this document based environment model-based system engineering. And Ed and Mark, you both mentioned this. When you get to the model-based engineering, there's one key word: integration, not standalone. And this is what Ed very much in detail described. It doesn't matter what type of model you have, integrated. Then you get to the model-based system engineering environment.
Very, very true. Well, I know we're over a little bit, but I think that was a great discussion at the end. So thank you, everyone, for staying on to listen to it. I think that was a key aspect of this presentation. But once again, thank you. If you have any questions, don't hesitate to reach out. We will be following up with all our contact information and a link to this recording.
Excellent. Thank you all.
Yeah, thank you very much.
Thank you. Ending the presentation now.